Chapter 1.1 Arithmetic Sequences. An arithmetic sequence is an arrangement of numbers where the difference between consecutive terms is a constant. Example, pick a number to start. I'm going to pick 6. Pick a number to add. I'm going to pick 3. Then write our sequence. Our sequence starts with 6. Then the next term we add 3, which is 9. The next term we add 3, that gives us 12. Add 3, we get 15. Add 3, we get 18, and so on. The number that we're starting with, that's the first term of the sequence, so we can call it T1, or sometimes it's called the A term. The number that we're adding, that's the difference between two consecutive terms, so that's called the D value. And then the sequence is the terms written in order, so T1, T2, T3, T4, etc. to Tn, n being the number of terms in the sequence. And as it says up here, the difference between consecutive terms is a constant. The difference is the D value, in this case that is 3. So if we take the difference between any two consecutive terms, those two are consecutive, those are consecutive, those are consecutive, those are consecutive. If we take the difference of any two of those, we would get the D value. So D equals T2 minus T1, which is 9 minus 6, which equals 3. Or I could pick D equals T4 minus T3. T4 is 15. T3 is 12, so 15 minus 12 equals 3. Let's pick another example. I'm going to do 17 as my T1, and then this time I'm going to do -2 for the D value. Then my sequence would be starting with 17. I subtract 2 each time or add -2, so I would get 15, then 13, then 11, and so on. And again, we can test to see if the difference between two consecutive terms equals the D value, which is -2. So if we did D equals term 4 minus term 3, which is 11 minus 13, that equals -2. If we did term 3 minus term 2, that is 13 minus 15, which equals -2. We can come up with a formula that will let us generate any term in a sequence. To do this, let's investigate the sequence 3, 7, 11, 15, etc. Term 1, the first term in the sequence, is 3. The difference, D, take two consecutive terms and subtract them, so I could take 11 minus 7, which equals 4. So my D value is 4. Then I have T1 equals 3, which equals the T1 term plus 0 times the difference. T2, which is 7, equals 3 plus 4, which equals term 1, 3, plus 1 times the difference. Term 3 equals 3 plus 4 plus 4, which is term 1 plus 2 times the difference. Term 4 equals 3 plus 4 plus 4 plus 4, which is term 1 plus 3 times the difference, and so on. So the nth term, Tn, would equal the first term, T1, plus how many times the difference? If we notice, term 4 has 3 times the difference, term 3 has 2 times the difference, term 2 has 1 times the difference, term 1 has 0 times the difference. So it's always 1 less than the term number. So for term n, it would be n minus 1 times d. That gives us a formula for the nth term in an arithmetic sequence. Or if we use a instead of t1, then we can have tn equals the a value plus n minus 1 times d. Finding and using the general term. Example, given the sequence -2, 4, 10, 16, etc., determine the general term and the 57th term. Start by writing down what we know. We know that t1, the first term in the sequence, is -2, and we can figure out d because we have consecutive terms in the sequence. So pick any two consecutive terms and find the difference. I'm going to take t3 minus t2, which is 10 minus 4 equals 6. So my d value is 6. Then I can write tn, the nth term, using the formula that I just discovered above, t1 plus n minus 1 times d. t1 is -2 plus n minus 1 times d, which is 6. Then we need to simplify the general term always, so multiply the 6 into the brackets. We get tn equals -2 plus 6n minus 6, and then combine our like terms. We get tn equals -8 plus 6n, or you could write that as 6n minus 8. Either one, doesn't matter. So that's our general term. Next, we want to find the 57th term, so we're going to use the general term that we just came up with to figure out the 57th term. So we do t of 57 equals -8 plus 6 times n, which is 57. Then we calculate. 6 times 57 is 342, so t57 equals -8 plus 342, -8 plus 342, that gives us 334. So term 57 equals 334. Example, the guideline for the growth of a child between 3 and 10 years is an average increase of 5 centimeters per year. Suppose a child was 70 centimeters tall at age 3. Write the general term that you could use to estimate what the child's height will be at any age between 3 and 10. Start by writing down what we know. T1, the starting height of the child, is 70 centimeters. And D, the difference, that would be the growth rate per year. So that would be 5 centimeters. Then we want Tn, which is T1 plus n minus 1 times D. It's on your formula sheet, or you can go back to the last page to look at it. Then we plug in what we know. Tn equals, T1 for this question is 70, plus n minus 1 times d is 5. Then we have to simplify this for it to be the general term. So make sure you do that on a quiz or a test. It has to be simplified. So tn equals 70 plus 5n minus 5. Combine like terms. We get, you can put the n first or last, doesn't matter. So 5n, 70 minus 5 is 65. So 5n plus 65 is our general term. Second part, how tall is the child expected to be at age 10? So at T1 is an age of 3 years. We need to add 7 years to that to get to 10 years. Which would be at T1 plus 7, so T8. So we're finding the 8th term using our general formula. T8 equals 5 times 8 plus 65. T8 equals 5 times 8 is 40 plus 65. T8 equals 40 plus 65 is 105. We would expect the child to be 105 centimeters at the age of 10. Finding the first term. The fourth term of a sequence is -5, and the fifth term is -1. What is the first term of the sequence and the 20th term? Start by writing down what we know. T4, the fourth term of the sequence, is -5, and T5, the fifth term of the sequence, is -1. What can we do with these two values? Notice they're consecutive terms, term 4 and then term 5. So if we find the difference, that's our d value. D equals T5 minus T4, which is -1 minus -5, which is -1 plus 5, which is a d value of 4. Then we go to our general term. So Tn equals T1 plus n minus 1 times d. We know the value of term 4 and we know the value of term 5. So we can fill in the information for one of those two terms. I'm going to do T4. So T4 would equal T1 plus 4 minus 1 times d. We know the value of T4 is -5, so -5 equals, we don't know T1, plus 4 minus 1 is 3, and then times the d value, which we determined is 4. Then we get -5 equals T1 plus 3 times 4 is 12. And then we can isolate T1 by subtracting 12 from both sides. And we get T1 equals -17. -5 minus 12 is -17. So we've got T1. Now we want to get T20. So we're now going to use the general term with T1. So Tn equals T1 plus n minus 1 times d. We're looking for T20. Our T1 is -17 plus n is 20 minus 1 times d, which is 4. And start to calculate. T20 equals -17 plus 20 minus 1 is 19 times 4. Times 4 is 76, so T20 equals -17 plus 76. -17 plus 76 is 59, so T20 equals 59. The number of cans in the rows produces an arithmetic sequence. The top 3 rows are shown. There are 14 cans in the 8th row from the bottom and 10 cans in the 12th row from the bottom. Determine T1, D, and Tn for the arithmetic sequence. So T1 would be the bottom row. What we're seeing is the top 3 rows. What information can we get from the picture here? The third from last row has 3 cans. Then the next row has 2, so that's minus 1. And then the next row has 1, so that's minus 1. So that tells us that D equals negative 1, which is part of the answer. We wanted T1, D, and Tn. So we've got 1 of 3. Now we need to figure out T1 so that we can write the general term Tn. Using the general term formula, Tn equals T1 plus n minus 1 times D. We know that D is negative 1, and we also have some other information. So we have that there are 14 cans in the 8th row and 10 cans in the 12th row. So we can use one of those, just like we did in the previous question, to fill into the general term and then to find our T1. I'm going to use the 12th row has 10 cans, just because I like the number 10 better than I like the number 14. So term number 12 equals T1 plus n is 12 minus 1 times D. We know T12, it's 10. There's 10 cans in the 12th row, equals T1 plus 12 minus 1 is 11. And we know D, we said that was negative 1 from our picture. And then 11 times negative 1 is negative 11, so we get 10 equals T1 minus 11. Then we add 11 to both sides. To solve for T1, we get T1 equals 21. And then the third thing we need to solve for is the general term Tn. Tn equals T1 plus n minus 1 times D. We now know T1, so Tn equals 21 plus n minus 1, and we know D is negative 1. Then we need to simplify it, multiply the negative 1 into the brackets. We get Tn equals 21 minus n plus 1. Minus 1 times minus 1 is plus 1. Then combine our like terms. You can either write the n first or last, it doesn't matter. I'm going to write it last this time because it's negative. 21 plus 1 is 22 minus n. So our general term Tn is 22 minus n. Finding the number of terms. Example, an arithmetic sequence has a first term of 7 and a common difference of negative 3. If the last term is negative 53, how many terms are there? Start by writing down what we know. The first term is 7, that means T1 equals 7. The common difference is negative 3, so D equals negative 3. We have the last term, we don't know what number of term that is, but Tn equals negative 53, and we're trying to determine what is n. Write out our general term, Tn equals T1 plus n minus 1 times D. Fill in what we know. Tn is negative 53, equals T1 is 7, plus we don't know n, minus 1, and D is negative 3. We want to isolate n, so I'm going to start by subtracting 7 from both sides. Then I get negative 60 equals 7 minus 7 is 0, n minus 1 times negative 3. I could multiply the negative 3 into the brackets and then isolate the n, or I can divide both sides by negative 3 to move it over now. I'm going to do that. Negative 60 divided by negative 3 is positive 20. That equals to n minus 1. And add 1 to both sides. We get n equals 21. Suppose that the growth of an ant colony produces an arithmetic sequence in which the number of ants increases by approximately 80 each month. Beginning with 40 ants, how many months would it take for the ant population to reach 3,000? Start by writing down what we know. T1, the population of ants at the beginning, is 40. The increase in ants each month is 80, so our D value is 80. The value of the term we're trying to figure out is 3,000. That's the population at the end of n number of months, and we want to know how many months that is, so what's the n value? Next, write our general term, Tn equals T1 plus n minus 1 times D, and then fill in what we know. Tn is 3,000 in this case, equals T1 is 40, plus we don't know n, and D is 80. Isolate the n, start by subtracting 40. We would get 2,960 equals 40 minus 40 is 0, so we have n minus 1 times 80. Divide both sides by 80. On the right side, 80 cancels out. 2,960 divided by 80 is 37, equals n minus 1. Add 1 to both sides. We get n equals 38, which is months in this question. That brings us to the end of Chapter 1, Lesson 1.